Hello again. Unit 2 Limits, subsection 3, Working with Limits, Part 2. Find the limit of rational expressions. Recall from Unit 1, we did extensive work with simplifying complex radicals in subsection 3, Part 3, and simplifying rational expressions and equations in subsection 6, Part 4. Please feel free to review these sections if you find it necessary after you've watched this video and whoa, I just don't remember how to do that. Okay, well, those are two parts that you can go back to and kind of review. So as a practice, I just gave you a couple of questions where you can look at and just get the basics again. So the thing we say to ourselves when we have polynomial expressions like this, or rational expressions, is how do we add fractions? Well, to add fractions, we need a common denominator. So that means I times this guy by x plus 1. Whatever I do to the bottom, I do to the top. Okay, and then times this guy by x. Whatever I do to the bottom, do to the top. So this one works out to x plus 1 times 1, which is just x plus 1. Okay, all over x plus 1, plus 3x squared over x plus 1. Okay. In an equation, usually we would cross off the bottoms, but this is just simplifying. So now that we have this, we just add the tops. So 3x squared plus x plus 1 over x plus 1. Okay, and there you have it. That's all. That's as far as I want to go to for now. So again, we get a common denominator and then add or subtract the tops. Okay. Same thing here. Before we get a common denominator, though, we should factor that. That's x plus 3, x minus 3. Oh, look, he's got the x minus 3 just like him. Okay, so really, to get a common denominator, I just have to times this guy by x plus 3. Okay, so doing that to the tops, I get 2x squared plus 6x all over x plus 3 x minus 3 minus 3 over x plus 3 x minus 3. So if we subtract the tops, okay, there's no like terms for any of these, so it's just 2x squared plus 6x minus 3 over x plus 3 x minus 3. Okay, again, a little later on, what we could do, or what we might want to do, is try and factor the top and see if anything else cancels. For right now, this is just practice. That's as far as I want you to go. Okay, so now we're going to apply the above skill to limits. Okay, remember the first strategy should be to factor in or substitute the value of x to see if it really is a 0 over 0 limit. Many students get fooled into extra work because you just look at this, start factoring, rearranging limits that are continuous. So like I said, it's a good idea to put that 3 in. Okay, so looking here, okay, so 1 over 3 minus 1 over 3, oh, that's 0. And then 3 minus 3, that's 0. So this is a 0 over 0 limit. Okay, it really is a good thing to check though. All right, so again, when we have these things, remember we're going to do the top part first. So we need a common denominator. So this is going to be basically, remember these cross multiply, so 3 minus x over 3x, right, because the cross multiply and the bottoms just combine, over x minus 3. Okay, well, that's x minus 3 over 1, so how do you divide fractions? Well, you flip and multiply. So this is 1 over x minus 3. Okay, oh look, these are those special ones, so they cancel off, leaving behind a negative 1. Okay, so this is the limit as x approaches 3 of 1 over 3x. Okay, sorry, pardon me, negative 1 over 3x, right, we left behind the negative 1. Okay, so now that we have gotten rid of the 0 over 0 part, okay, now we just substitute the 3 in. So 3 goes into the x, so we get negative 1 over 9. Neat. Okay, so recap, get a common denominator, add the tops and the bottoms, okay, and then how do you divide fractions? You flip and multiply. Okay, so then we cancel off, leaving behind the -1. Okay, and once the 0 over 0 is canceled, we just substitute the 3 in, leaving us with our limit. Okay, number 2. Okay, so same kind of idea, just remembering that that is 2 over 1. So again, when there's only 2 binomials here, we can cross multiply. So this is the limit as x approaches 0. Okay, there, I didn't follow my own advice again. Okay, 4 divided by 2 plus 0. Oh, okay, that's just 2. 4 divided by 2 is 2. So 2 minus 2 is 0, and then x is 0, so this is 0 over 0. Well, it's a good thing because I kind of designed them to be this way, but still. Okay, anyways, moving along. So that 1 multiplies up to a 4 minus 2 plus x. Okay, all over 2 plus x. Okay, and then that part is all over x. Okay, so we do a little bit of rearranging here. Okay, so that's going to be 4 minus 2x over 2 plus x all over x. Oh, look, the 4 minus 4 cancels. So really, this part is the limit as x approaches 0 of -2x over 2 plus x, all divided by x. Remember, that's x over 1, and then we flip and multiply 1 over x. Okay, here, let me go right in red here. Okay, and then this x cancels off with this x, so you end up with the limit as x approaches 0 of -2 over 2 plus x. Well, we've canceled off the 0 over 0 part, so we just substitute the 0 in, -2 over 2 plus 0, well, 2 plus 0 is 2, so -2 over 2, 2 over 2, which is just -1. Ta-da!
Example 3. Find the limit as x approaches 4 of x to the -2 minus 4 to the -2 all over x minus 4. Okay, so remember, this is the limit as x approaches 4. So x to the -2 just means 1 over x squared. Minus 4 to the -2 is just 1 over 4 squared. Remember, 4 squared is just 16, all divided by x minus 4. Okay, perfect. So now that we have it in this form, we should double check to make sure that this is a 0 over 0 limit. Okay, so we put in the 4, so 1 over 4 squared is 16, so 1 over 16 minus 1 over 16, so that's 0 on top, and then 4 minus 4 is 0 on the bottom. So remember, with a 0 over 0 limit, we need to do some factoring to try and cancel off the 0 over 0 part. Okay, so first things first, what we're going to do is we're going to make a common denominator so that we can add, or well, in this case, subtract these fractions on top. So this is the limit as x approaches 4. Okay, so remember, the 16 is just going to multiply up, so we get 16. The x squared is going to multiply up, so minus x squared. And then the two bottoms just multiply, so 16x squared, all divided by x minus 4. Okay, great. So first thing we notice here is the 16 minus x squared. That is a difference of squares, so we can factor that. So we get the limit as x approaches 4 of 4 minus x and 4 plus x. Okay, all divided by 16x squared, all divided by x minus 4. Okay, that's great. Now remember, how do we divide fractions? Well, we flip and multiply. So we put the x over 4, or x minus 4, sorry, over 1. Okay, and then we multiply that. So we flip the fraction over, so 1 over x minus 4. Okay, awesome. Now let's see what cancels. So remember, this is a positive x and a minus 4. Okay, this is a positive 4 and a minus x. This is a positive 4 and a plus x. Nothing cancels off right away. They're not the same. However, remember that factoring trick is if they are the same stuff, just different signs. So look, this is a positive x, that's a negative x, that's a minus 4, this is a positive 4. So this one will cancel off with that one, leaving behind a negative 1. Okay, so there goes the 0 over 0 part. Okay, so this is still the limit as x approaches 4 of 4 plus x over, 4 plus x times negative 1, can't forget the negative 1, that's got left behind there, all divided by 16x squared. Okay, the 0 over 0 is gone now, so now we just have to multiply or put the 4 in, multiply and divide to get our final answer. So this is going to be 4 plus 4, which is 8, times negative 1, which is negative 8, and then 16 times 4 squared. So when we type that in, that's of course 256. So 16 times 16. Okay, and of course that reduces to negative 1 over 32. So that is our final answer. All right, guys, thanks. We'll see you next part.